Good evening, everyone. All of us know the danger of climate change and global warming, and it is predicted that over one third of the Earth's animals and plant species could be extinct by 2050 if current greenhouse gas emissions trajectories continue. Further, we are experiencing the effects of climate change and know the catastrophic effects it has, like the rise in sea level and increase in number of natural disasters. To discuss this further, we have organized this webinar with the Breakthrough Science Society, one of the biggest science societies in the country. Today with us, we have Dr. Today we today with us we have Dr. Moinak Mandal, who did his MTech from IIT Kharagpur, PhD from Australian National University, and is currently working at New York University, Abu Dhabi. He is also the member of a broad chapter of Breakthrough Science Society. Sir, we are grateful to have you here today with us.
Thanks for the kind introduction. Today I'm going to be talking about climate change and what can we do about it. So without further ado, let me share the screen. Okay, so the topic of my talk today is present trends in climate change and its solutions. So most of you have already heard this word climate change, and this is something we know, most of us know it as some kind of information or probably a GK question, but we have we know very little about what's actually happening. So when you talk about climate change, there are two words. First is climate and second word is change. So we can understand something is changing. So then we ask this question, so what is a climate? So generally when people talk, people say, what is the climate of that particular place? So we associate climate with a particular place. And we would say, what's the weather today? So when we say weather, we mention something that is happening in present. So climate is nothing but the mean of the weather at a particular place. So it's a long-term average. But here comes the problem. By long-term, what we mean, how long? So there has been some textbook definitions, but these days that definition is changing. And that's what I'm going to talk about today. So I would start by showing you some a video. So over here, what you can see. Sorry. Okay. What we can see here is the distribution of cloud from a satellite image. So this is the entire Earth, and what you can imagine is Earth being a sphere, it kind of cut in the middle and stressed out. So the top and bottom part is actually stressed because otherwise you cannot put it in a square. And then what you can see is the patterns of cloud forming through different satellite images. Now, one thing I want you to focus on, just a second. Okay, let me stop it here. One thing I want you to focus on, look at the pattern. How is the pattern at the equator and how the pattern changes in the northern and southern pole. One thing, if you can notice, that this pattern at the center part, these are much more prominent. Oops, sorry about that. these patterns are more prominent, and the scales of the pattern is much smaller. As you go on the north or southern pole, like towards Greenland or Antarctica, these patterns are more regular and bigger in size. What does it mean? These patterns are very irregular, very erratic, and these patterns, they have stronger flow, but they are bigger in structure. By that I meant there are 100 kilometers, even 1,000 kilometers, each structure. So this is how the weather pattern in an overall sense. Now let's look at how this weather pattern changes over different months. Let me play that again. So you can see over the January, this part, it's somewhat quieter, although in June, you can see there are a lot of structure appearing, maybe some of them are cyclones, and these over this entire band, you can see a lot of formations of storms and clouds. And then we move on to August, and you can see that these structures are somewhat weaker, but we have more structures and rainfalls and cyclones happening. Let's move on to October, and you can see also this kind of activities. So what causes this kind of disturbances and all those activities? And the main reason is the Earth is a sphere, and its axis is tilted. So being a sphere, that means the equatorial part would get more heat, and as you go towards north and south pole, it captures less amount of heat. So more heat means more chaotic, more turbulent, and then this part, you have bigger structures. So based on different times of the month, the inclination or tilt of the Earth changes, and that changes the pattern of the weather. It shifts, it goes down, those bands of structures that I just showed, it goes up and down. So this is what an overall view of the global weather. And this is just the atmosphere. So the question comes, atmosphere is by mass, it's just 1% of the total mass of the entire ocean. But atmosphere is almost 10 kilometers high from the ground. And so the thick atmosphere I meant, it can extend up to a few thousand kilometers up in the air. But and similarly, the main ocean is on an average 7 kilometers deep throughout. But the mass of the ocean is 1,000 times more the mass of the atmosphere. And the heat capacity of the ocean is also almost 1,000 times more than the atmosphere. So ocean is a much stronger driver of this climatic system. But what drives the ocean? So before discussing that, I want to show you two videos or two experimental videos. Now this guy, what he is doing here is he mixed this blue color is a salt solution, and then this red color is just plain water dyed in red color. And let's see what happens when he pours the dense salty water over the fresh water. It sinks down, right? Now, on the other hand, I'm going to show you another experiment. So this is, so this experiment, This is a fresh water in a cup, and then this is a salt water in a transparent cup. And then what he does, he pours 2 cubes of ice, and that is dyed in blue color. The ice cube is just the regular ice, regular water frozen. And let's see what happens. Oops. And let's see what happens when he drops that ice cubes. So this is fresh water and this is salty water. You can see as soon the ice is dropped, some flow is appearing and it's going down. But you can't see this kind of flow going down on this cup. Let's play that again. It's mixing. And then after 4 minutes, the freshwater ice cube completely melt away, but the saltwater ice cube is still floating. Okay, now what I just showed in this 2 experiment. Saltwater is denser, so if you mix saltwater in a freshwater, it sinks down. So this is an effect of density. So it has more salt, that's why it's denser and it sinks down. On the second experiment, I showed you an experiment. The only difference is we introduced a change in temperature by putting an ice cube. What happens here is that when the water cools, it becomes denser and it creates a flow. This kind of flow, we call this flow is convection. And what it does, it is a very efficient way of transferring any material or any energy. That's why it transfers the heat into the ice much quicker and melts the ice. Whereas over here, what happens when ice melts, it creates a fresh water, and fresh water sits on top of salty water like you seen here, and this kind of restricts the flow. So this flow cannot continue, and that's why this melts it takes longer to melt. So in global ocean, you have both the temperature and salinity playing a role. And this actually creates a convective circulation, what I'm going to show you now. So on to your left, you can see an animation from NASA. This is focusing on top of Greenland, and those arrows you can see, these are how the ocean flows are going. Now, what is happening here is that when you cool the water, so the water, this is essentially the oceanic salty water, and when this water reaches towards pole, it freezes. So the water freezes, and in the freezing process, the salt gets separated from the water, and the water turn into ice, and all the salt that is released, it's mixed into the surrounding water. What it does, it makes the water much more denser. So as the water get more and more dense, you're gonna see that it would try to sink, where you can see it from here, that when the dense water actually goes to the pole, it sinks down and it flows in a different path across the world. And this path you're seeing, these are the path that ocean circulation takes. One interesting thing about this ocean circulation, and I would like to point out, look there how the flow structure looks like. So this is a computer simulation, and this is something I've been doing, and Show is my ex-supervisor. So these are run on supercomputers. So this is actually crunching 10 billion grid points every time, and it is using 5,000 CPUs to produce this kind of image that you can see. So this particular animation takes around 1 year to complete, one entire full year. And this is the flow structure, which is going scales of thousands of kilometers to up to few meters. So you can imagine how detailed we are trying to measure or predict how the ocean circulates. So one thing I would like to point out here, that there is a mean flow which is going. This is a mean flow. So there are certain mean flows that is going. On top of that, you have a lot of eddies, like those whirl kind of structures. And these eddies is the culprit that we climate scientists struggles a lot. And the reason is that these eddies, they are so complex in structure and they are so tiny. So earlier in the older scientists, or like back in those days, when we didn't have enough computation, we used to sort of take an average value of the impact of those tiny eddies to the when it comes to predictions. But as we understood more and more through different research and data collection, we found that although these are small in structure, but it has a very high impact on how the global circulation would look like. And because they are so chaotic, that is why it's very difficult to predict the climate or the weather precisely. But we have gone much farther what we used to be, and we were able to predict in I would say almost 60% better what used to be in a decade ago. So climate is complex. It's an interplay between atmosphere and the ocean. It has different scales of motion, almost half the size of the globe down to few millimeters. And that is why it's very chaotic. And that means it's very sensitive to the trapped excess heat from greenhouse effect. So any slight changes, sometimes it would just be absorbed and nothing would be reflected later on. But next time, any slight change can have a drastically different effect on a large scale. So I just mentioned here greenhouse effect, right? So we all know what greenhouse effect is, and we might have seen those pictures. I think that's boring. So let's see it from a different perspective. Let's see how the greenhouse effect looks like. Let me show you this video.
I can show you how carbon dioxide affects Earth's climate using this heat-sensitive or infrared camera, which is purring away here. A candle, this glass tube, which is hooked up to this rather large canister of carbon dioxide gas. Now, if I light the candle, you'll see that on the monitor, the camera picks up the flame perfectly. Look at that. The hottest parts are glowing white. Now watch what happens when I turn on the carbon dioxide. Just keep your eye on the flame. The gas is invisible, so you don't see it fill in the tube. But as it comes in, you should see the candle start to disappear. There it goes. Look at that.
Okay, so what do we see here just? That guy is doing an experiment, and this experiment is getting conducted in this enclosed chamber. And what he just did is he lit up a candle, and he has a camera that can take photographs of the temperature, like a thermal camera. And he was taking the photograph of the flame. And he could see the flame just as it was, it looks like. And then what he did, he filled that chamber with carbon dioxide. And once he did that, on the thermal imaging, that image was kind of gone, because all the heat that is coming from the candle is getting absorbed inside the carbon dioxide. And this is what a greenhouse effect looks like directly. So getting back to this image, this is the Earth. We are getting solar radiation. Some of them is absorbed at different layers. Some of them are getting reflected. And then what is getting reflected, some of them is getting trapped by this greenhouse layer of gases, and that is increasing the temperature. Okay. So when it comes to this change in global climate, there has been this prolonged question, whether is it natural or is it that we human started it? So in order to understand that, what scientists did, or I would say rather the paleoclimate scientists, those are the guys who would investigate what temperature we have at a certain place, maybe 500,000 or like 1 million years ago. And how do they find this? Well, they would collect rock samples, they would collect based on the rock samples, or they would collect the sediment samples, and they would see that there are different kinds of fossils of different, different phytoplanktons. And they would try to find certain isotopes. One of them is called the delta 18O, which is one of the prominent tracer. And based on their concentrations, they can calculate how the temperature was like. And what we have seen here is that over 1 million years ago, the temperature, the carbon dioxide level has gone up and down, and this is in order. By that I meant the level never went above 300 parts per million. But see what happens at present day. We overshoot this concentration and we are at all-time high. And nothing else has changed except for we human changing the climate. We are constructing buildings, we are making different machineries that runs on fossil fuels. We set up industries, a lot of emissions coming out from them, a lot of vehicles, a lot of people, a lot of burning, and we have increased the level of carbon dioxide off the top. So this is one of the reasons. The second reason I want to show in this video. Oops. Let me play this. Just a second. Okay. I'm going to play this YouTube video. You can go and check yourself. So this is showing how deforestation has been happening over the Amazon rainforest, which is the largest carbon sink. That means it has a largest source of plants, like the big plants that absorb the carbon dioxide, or rather sequestrate the carbon dioxide. So this is in Bolivia. You can see how drastic the change is. So this is over Oregon. And this continues. So the bottom line is there has been unprecedented deforestation, be it for development or be it just for logging, and by logging, illegal logging, and the greed of the people. So we have so before 1950s, or sorry, before the pre-industrial era, based on the fossil fuel record, we would have 6 trillion trees over the entire globe. And at present, we have less than 3 trillion trees all over the globe. And this number is constantly decreasing. And the sad thing is that the trees, they actually absorb more than 25% of the excess carbon dioxide that prevails in the air. And by cutting down the trees, not only this absorption is getting reduced, but if you open up a land, the land becomes barren, and then it has and so it evaporates the entire region, and that has a severe impact on the agriculture and the global climate as well. So that brings me to this IPCC report that was published around 8 months ago. So IPCC is an acronym for the Intergovernmental Panel for Climate Change. So it comprised of almost 4,000 scientists all across the globe, and from 190 different countries. And they all came together, they studied, and they sort of accumulated all the knowledge from different studies. And what they have predicted is this. So 8 years back, we had the similar kind of assessment, and that brought to the Paris Agreement, where the global leaders meet and they agreed that they would reduce the amount of carbon dioxide so that we don't have an increase in global temperature. That was passed. What it stands now is that we have crossed the point of no return. By that I meant the amount of carbon dioxide and other greenhouse gases we already put in the atmosphere has gone too far. Even at this very day, if we stop using any kind of fossil fuels and stop emitting carbon dioxide, we would still get to see almost an 1.5 degree changes in the global mean temperature by end of the century. But this is too much. I would say this is very unrealistic, because that is something that's not going to happen, and it's too optimistic. So what the scientists are expecting now is that by 2050, we would see around 2-degree rise in the global mean temperature. And by end of the century, we would see almost 3.8 to 4-degree rise in the global mean temperature. Listen here, when I say global mean temperature, it's actually an average of temperatures all across the world. Since it's a mean temperature, the actual temperature at a particular place can be almost 2 to 3 times higher. So the change in temperature. So what I'm saying that, suppose in Delhi, I don't think it would be in Delhi, but in other places, say for example, in summertime, the mean temperature used to be 35 degrees. There you get to see an increase in temperature to up to 40 degrees. And there are other places where instead of warming, you get to see cooling. And some very few places, they would see a minute change. So this change in our localized redistribution of heat has severe impact on the local weather. And what it could do, well, when you have high heat, or the days where the number of hot days in a year increases, the atmosphere also has a lot of heat, and it melts all the ice caps. So in India, we have a big reservoir of fresh water, and that's on the Himalayan snow covers. And this is a source of fresh water, which is extremely important for all the people. It's used for cultivation and many other things. So when you see an increase in temperature, all the predictions are saying that there would be increase in the melt from those snow caps. That means suddenly over the next few decades, you would see a gradual increase in the flow of the river during summertime. And then, late summer to rainy season. And then during winter season, this flow would be very, very less. As you progress through time, even during summer, when most of the ice cap melts away, there won't be any ice left to produce fresh water. So we would see a drastic drop in the flow of the river. And that would have a severe impact on the agriculture and the economy. The second thing, which is the next bigger problem we would see, is extreme weathers. So Bay of Bengal and Arabian Sea on the west and east part of India, these are the birthplaces of very destructive tropical cyclones. And as the atmosphere and the ocean is getting warmer, that part of the ocean is more likely to produce cyclones. And these cyclones, they would get much more energized, because as the atmosphere is warmer, it would evaporate the water more. So more evaporation, that means it has more moisture in the air. Now, all those atmospheric systems, they would get their fuel as the moisture, because when the water converted into water vapor, you put some kind of latent heat inside them. And when those water vapor converted into back to water, it releases those latent heat. And this heat is actually driving this kind of circulations. So more heat means more severe cyclones. And we all know what happens when you get hit by super cyclone. Like we have so many, you name it. And we have also seen the amount of destructions that they cause. So we have those more tropical cyclones coming. All the coastal areas are getting flooded. There are storm surges because as the cyclone passes, it sucks up the ocean water and then just throws that water on the coast where it makes landfall. And so it disrupts the agricultural cycles, it disrupts the economy. So, and what it means is that over those vulnerable regions, there would be more climate refugees, and they would have to migrate to other parts of the India where you don't have that extreme weather. That means in certain parts, they're more likely to create disputes, like land disputes, several other disputes, and we are looking towards a very chaotic time. So this doesn't look very good, and it's time that we should act now. So this is what this IPCC report says recently. The blue line over this plot, where is my cursor? Oops. Anyway, so the plot A on the screen is showing that different projection scenario. So we are now standing on 2022, and depending which pathway or which mitigation we choose, our future climate would look quite different. SSP 1.9 is the most optimistic as well as unrealistic scenario, where we stop using stop using all those emissions, and we see after 2050 a very gradual decrease in the temperature. The SSP 4.5, which is the most realistic scenario, that too has a lot of uncertainties. So this would have almost a 2.5 degree rise in the temperature with the amount of mitigation that is already taken place. And it also shows how much biodiversity loss and other loss is going to happen. And this is quite a detailed report, and I would encourage everyone go and have a check from the website if you can. So the overall picture is that there are possibilities and there are certain measures we can still take, and that could have a positive impact on the climate. But these are global scenarios, and let me come down to India and what it says for India. Well, it says that the 1.5 degree to 2 degree is a very likely scenario, and then the extreme weather show the intensity of the cyclone or extreme weather is increasing quite a bit. Like it would say in a realistic scenario, it's almost 4 to 8 times what we see now. So India has huge amount of population across the coastal area. And as we know, as the ice is melting, all the meltwater is getting into the ocean, and the meltwater is fresher, it's mixing with salt water. When it mixes, it also expands. So there are combined effects of fresh water from the land, which was stored as chunks of ice, now is mixing into the ocean, and it increases the volume. At the same time, when fresh water is mixing with salt water, it's expanding in volume. The combined effects are rise in sea surface temperature. And that rise is also depending on where you are at the globe. Unfortunately, Sundarban region and runoff in the Gujarat region, these are the most vulnerable region in the next few years to come. And over that region, we would see much severe rise in sea surface height. That means inundation, loss of lands. The agricultural land would be barren, would convert into barren land because a lot of groundwater pollution because salt water would get into those groundwaters. And also we would see lot of inundation across. So what we can do, let me go back to that. Or is it like we just do nothing and do not react and just let things happen as it is? Or we could do something. So let's look at what implications we have. So back in late 2019 and throughout 2020, we have lockdowns, and that kind of restricted the economic activities, and that has impacted on the release of all those carbon and those greenhouse gases. So let me show this video. So it's showing that in Beijing, during lockdown, the emission reduced. These are air quality index that is showing at the over United States. And this is showing that the product supplied in US, how it dropped to 31%. And then the yearly change in global emission dropped to almost 2000 gigaton. And then, but this was temporary because in few months, all those, the air quality was back to normal. So that just shows a glimpse of what can be done. It was a different emergency, but this has shown that if we can react, we can make quite a significant amount of change. But these are all the things that I've been talking about is theoretical. If this could have been done, this could have happened. And sometimes people would just get bored. So they would say, is there anything that really happened? Well, let me tell you something. There is something we human did, and that really we tackle the change in climate to a certain extent. And that is what I would say is known as the Montreal Protocol. So what this Montreal Protocol is, so let me show you this. So if you remember back in 80s, for refrigeration, we used to use chlorofluorocarbon, other gases, and this gas would make holes in the ozone layer. And then because of it.
Sir, I would request you to please complete the presentation in the next 5 minutes, and then we can have the questions.
Yeah, sure. I'm on the last slide.
Yes.
So Because we could control the emissions of those gases that creates a burn, that burns a hole in the ozone layer, we have actually, we could have a worse scenario. And this simulation shows that had this not been checked, we would have another 1 to 1.5 degrees centigrade of global rise and almost 150 to 300 ppm, which is parts per million increase in the global carbon dioxide. So with this, I would like to end my talk on this note that we have evidence and we can have certain realistic protocols to tackle this climate change. There are certain things that the government needs to take care of, especially the forest covers and the forest conditions. Unfortunately, the government is playing a number game. Recent report says that we have an increase of 0.2% in the entire forest, which actually doesn't include the sparsing of the forest. The forest conditions, what used to be and now is very different. And the report even says in 1 hectare land, if you have just the 10% of the land with dense trees, then you consider that part as a forest land. So in this way, a lot of lands has been already incorporated as forest lands just to increase the number, but that doesn't change the scenario. So we would have to act properly. And as for individual perspective, we have to change certain practice, like not throwing trash, try to take public transport, not to waste electricity, and don't burn trash. So with this, I would like to conclude this talk, and I hope you would have questions, and I'm open for questions. Thanks for listening.
Thank you, sir. I would like to inform everyone that they can use the YouTube feature to ask the questions. And now, sir, we are taking the questions. Sir, I'm seeing a question from YouTube. So someone has asked that, sir, how much is the mechanism of global warming understood right now?
So global warming, when you say global warming, there are certain factors that affects them, and which is atmosphere and the ocean. And we are getting very close. It's very difficult to say how much percentage we learn, but I can tell you how we have improved in the sectors we have improved. And the main reason I mentioned at the beginning of the talk is that the scientist and the or like who predicts, they mostly used to look at the larger scales, like what happens globally, and ignoring the fact that what is happening locally and in smaller scales. With higher computation, we are 60% more confident in our prediction. And that happened over the past 8 years. So if you have read the IPCC report in 2015 and 2022, it says specifically that it's with very high confidence. And that all happens because we have better tools and we have better knowledge of the physics of climate. And so maybe in another 20, 30 years, we would have enough knowledge. And I hope this number can go up to 80%.
Yes, sir. Thank you, sir, for the answer. So we have another question. Sir, some person is asking that right now we have a lot of climate change models that which are modeling the future and predicting what will happen in the future. Sir, how reliable are these models, and is there any proof that they are actually reliable?
They are reliable. That's why the IPCC took 8 years to publish this report, because they had been, over the past 8 years, they have been collecting data and validating the model. So even if you see these days, like, I don't know, 10 years back, if you remember, so there are different weather apps, and so what it used to predict and or broadcast and TV, people used to mock it, because if it says it rain, it's gonna rain, it won't. But these days you can't say this. So you would always check the weather on your Google app or whatever app you're using, and you trust them, aren't you? So we come across a long way, and we are getting close to perfection.
Yes, sir. Thank you, sir. Sir, now I will request Jessica to ask the question.
So another question that popped up was how much of global warming is caused by anthropogenic effects?
So if you, in one of the slides, I showed that how much release of carbon dioxide has happened over the past 10, 15 years. And so the recent report, IPCC report for the working group 2, the working group 1 being those who deals with the dynamics of the climate, like the motions and the patterns, and the group 2 being who actually invested in the impacts. So it's quite eminent that it has changed quite a bit, and the impact is very evident.
Right, sir. A common misconception that many people have is that the climate change and global warming are problems of the future. So can you clarify it?
So when we say problems of the future, the problems comes in few different directions. So first problem would be the land you live in, right? So in the coastal areas, when you have sea level rise, there are a lot of inundation, a lot of coastal flooding, and then you cannot build structures across the coast, because if it's keep hit by cyclones, you have to move from that place. So the first problem would be the problem of land. And on top of that, we have very high rate of population growth. So we have to accommodate all the people, and that is another challenge. The second thing would be, once you have a place to stay, you need to have fresh water. Because of the climate change, the groundwater is getting saltier, and also all the things I talked about, how the river discharge is going to change. So we would have problems on fresh drinking water. And the same thing goes for cultivation. So you need water to cultivate. If your temperature is too high, certain plants can't grow the way it used to grow now. So your crop yield would drop. Once the crop will drop, you don't have enough food to eat. So you have to import. That would have high impact on the economy, because if you are importing all the food from outside, you cannot survive. It's not a sustainable system. Next thing you would have is the working conditions. So we human, we can work, and we have a healthy human would have a fixed body temperature around 37 degrees. If the outside temperature is more, we have a natural mechanism to cool down by sweating. So as we sweat, the sweat evaporates and it cools down. Now, as the temperature is increasing, the amount of water vapor that would have in the air would also be very high. So even if you sweat, you would hardly cool down. So, and it says that if the wet bulb temperature that incorporates like the amount you can actually feel the heat by cooling down by perspiring, that would, if that increases more than 37 degrees, that is the functioning temperature of the human body, you cannot do any physical labor. So if outside temperature is like this, the heat waves are more prolonged and you cannot work. So all the economic activities is going to be, it's going to hamper. So all in all, it's far-reaching impact. And these are all the things that are going to happen maybe in 20, 30 years from now. So this is not future, but these are near future events.
Right, sir. These are all the questions. Thank you so much for answering them so wonderfully and for such an informative presentation. We really appreciate how you gave us such a new perspective on global warming and climate change.
I'm glad you enjoyed it.
Yes, sir.